Trusses. Analysis of simple trusses part 1 presented by Professor Khamkar U B, VAPM Almala. First of all, what is a truss? A structure composed a number of straight members connected together to form a rigid framework, usually composed of interconnected triangles. Members carry load in tension or compression. Now, types of trusses. Plane truss. When members of truss lie in a single plane, the truss is called plane truss. Rigid truss. A truss which does not collapse when loaded is called rigid truss. Simple truss. The structure built from a number of triangles connected together is called simple truss. Now, component parts of trusses. This is a truss. Bottom horizontal member are called as bottom chord. Top horizontal member are called as top chord. The inclined members are called as diagonal. The vertical members are called as vertical members. The end inclined portion are called as end post. Now, different types of trusses useful in construction, that is Howe truss with 4 and 8 panels, Pratt truss span 6 meter to 30 meter, the modified Pratt truss span 6 meter to 100 meter, simple Fink or French roof truss, the span is 6 meter to 9 meter. There are another different types of trusses used in industrial structure, mostly preferable structure. North light roof trusses span 8 meter to 10 meter. Now, what is the classification of trusses? According to truss, truss is mainly classified in two types, that is perfect truss, which is also called as stable truss, imperfect truss, which is also called as unstable truss. The imperfect trusses are again classified in two types, that is redundant truss and deficient truss. Now, detailed classification of trusses. First one, perfect truss. A truss which does not collapse under the loading is called perfect truss or stable truss, or it is also defined as it is the simple frame in which the number of joints and number of members satisfy the equation n is equal to 2j minus 3. Such trusses are called perfect trusses. This is the example of perfect truss. This is one triangular truss A, B, C. There are three joints A, B and C. Hence, number of joints are J is equal to 3 and number of members A, B, B, C and AC 3. Therefore, 2J minus 3 is equal to 3 is equal to 3. Therefore, n is equal to 2j minus 3. So, triangular truss is an example of perfect truss. Now, move on imperfect truss. Imperfect truss, a truss which collapses under the loading, is called imperfect truss or unstable truss. It is also defined as it is the simple frame in which number of joints and number of members does not satisfy the equation n is equal to 2j minus 3. Such trusses are called imperfect truss. This is the example of deficient truss and redundant truss. Redundant truss, it is the simple frame in which the equation n is greater than 2j minus 3. Such trusses are called as redundant trusses. Deficient trusses, it is the simple frame in which the equation n is less than 2j minus 3. Such trusses are called deficient truss. Now, move to example. This is the first figure is deficient truss and second figure is redundant truss. In first figure, number of joints are 4 A, B, C and D, and number of members are also 4. Hence the equation is here n is less than 2j minus 3. Therefore it is called as deficient truss. Second figure is the number of joints are 4, which are A, B, C and D. Number of members n is equal to 6. Now move the what is analysis of truss. When truss is loaded, the members are subjected to axial forces, either tensile or compressive. The determination of these axial forces in both magnitude and direction is called analysis of trusses. Methods of analysis of trusses. The first is method of joints, method of sections and graphical method. While analysis of trusses, some assumptions are made, which are: the frame is perfect frame, that means the frame satisfies the equation n is equal to 2j minus 3. All the members are hinged or pinned connected at the ends. The loads are acting only at the joints. Self weight of the member is neglected. These are the some structural member which is utilized while design or construct the structure: solid rod, solid bar, hollow tube, I shape. These shapes are called as cross sections. Types of truss connections: pinned connection and gusset plate connection. This is the pin and this is the gusset plate. Nowadays modern bridges use gusset plate connection. Most preferably connection is gusset plate connection. Force, loads and reaction. There are two types of forces: one push force or second pull force. Loads, a force applied to a structure, which are self weight, weight of vehicle, pedestrian, snow or wind, etc. Reaction, a force developed at the support of structure to keep that structure in equilibrium. Now we see one example of simply supported truss. The truss is simply supported and it have A, B, C and D 4 joints, in which in this truss a load is hanging 2.5 kg at joint B. The span AB is 15 cm, span BC is 15 cm and the height of truss is also 15 cm. Now we convert this 2.5 kg mass in Newton, while after this load is distributed on these two supports, that A and C, which is also called as reaction RA and RC. Now F is equal to MA, therefore the total force on joint B is 24.5 Newton. The free body diagram of the given truss. Reaction RA and RC. Now we calculate the reactions. The total downward force is 24.5 Newton. The total upward force must be 24.5 Newton to satisfy the condition of equilibrium. Hence, the force is acting at the center of the truss. Therefore, RA and RC must be equal. RA is equal to RC is equal to 24.5 divided by 2, which is 12.3 Newton. Therefore, RA is equal to 12.3 Newton and RC is also 12.3 Newton. Now consider first joint A, which is also called as isolate a joint. Now we take joint A to analyze the truss. At joint A, the known reaction or known force is 12.3 Newton and unknown forces are these two. We draw a free body diagram of joint A, which includes the external loads of the reactions applied at the joint. This is first force FAB. This is second force FAD, which we calculate by using equilibrium condition. First equilibrium condition, the sum of all forces acting in the x direction must equal to 0. That is, the sum of all forces acting in y direction must equal to the 0. Now component of FAD. The FAD force is resolved in direction of x and direction of y, which is called as FAD in x direction, FAD in y direction. The two forces are resolved by using theta angle. The angle is 45 degree by using Pythagoras theorem. To calculate the direction force in x direction, x is equal to h cos theta. Therefore, FAD x is equal to 0.70 FAD and y is equal to 0.70 FAD. Now, using equations of equilibrium, we calculate FAD and FAB. The first equation is summation of f of x is equal to 0. The resolution of these forces are 0.707 FAD, 0.707 FAD. The horizontal forces are 2 FAB and this is 0.707 FAD. Therefore, both are going to right direction. Therefore, both are taken as a positive. FAB plus 0.707 FAD equal to 0. Therefore, FAB is equal to minus 0.707 FAD. Now, second equilibrium condition, summation f of y is equal to 0. In vertical forces, this is first force 12.3 Newton and second force 0.707 FAD. Both are in upward direction, therefore we taken as a positive. By solving this, FAD is equal to minus 17.3. This FAD value we put in equation of summation f of x and calculate FAB. Therefore, FAB is equal to plus 12.3 Newton. The value of FAB is positive, that is tension, and the value of FAD is negative, that is compression. Now we consider second joint, that is B, joint B, and isolate that joint. And for further calculation, we draw a free body diagram of joint B and calculate the other forces, first, second and third, which are FBC, FBD, FAB, in which 24.5 Newton in the downward direction and FBD in upward direction. Summation f of x is equal to 0. While applying this equilibrium condition, the horizontal forces are two, one FAB and another FBC, in which FAB going in left direction, it is taken as negative. FAB plus FBC is equal to 0, while FBC is already calculated, which is 12.3. Therefore, FBC is equal to 12.3 Newton, which is tension. Now second, summation f of y is equal to 0. FBD is in upward direction taken as positive and 24.5 Newton in downward direction taken as negative. So minus 24.5 plus FBD is equal to 0. Therefore FBD is equal to 24.5 Newton, which is positive. So these are the forces. The forces in the member FAD 17.3 Newton, which is compression. FAB forces in the member AB is 12.3 Newton, that is tensile force. All these types of forces are calculated in each member. These forces in the form of tabular format. In part 2 we will discuss about the cantilever truss analysis.